I don't want to praise them too much, but they were state champions in math counts. And they're going to come tell us some further problems here that are a variety of different types of things. And so Joby, I think you're going to start. Come on up here. I'll get you mic'd up, and then we'll go. And Joby, you can see the problem over there if you need to, or there, yeah. Let me get this for you. Can I put it on this string here?
Yeah.
How's that? And then, is that gonna hold on?
Do what?
Okay, and you can just put that in your pocket. Cool. All right.
Okay. Do I like click something to go?
No, take care.
Okay.
You just can use the pen and the eraser. Walk us through. And you can go. I know. Yeah.
Sorry. The first time I can see the QED count.
Now it should work.
Okay.
Great. You can tell us what the problem is.
Okay. So it says right there. So this problem is a sequence is defined as an equals 1/2 times the quantity an minus 1 plus an plus 1, and then given that an or a1 equals 2 and a3 equals 8, what is the value of a4? Okay, so it says that an equals 1/2 times an minus 1 plus an plus 1. Now, it also says that a1 equals 2 and a3 equals 8. And we're trying to find a4. So, well, like what this means is if we plug in a4 here, that'll be a3 because minus 1, and then that'll be a5 because plus 1. And then, but if we plug in a4 here, we're going to get a3, which we know, but then we'll get a5, but we don't know a5, so we can't like use a5 to solve for a4. So instead, we could put in a3 here, and then we'd get a2, and then a4, and we can get a2 easily, and then we can solve for a4. So the first thing, to get a2, we just set this equation to be a2, so 1/2 times a1 plus a3 is equal to a2, and we know a1 is 2, a3 is 8, so 1/2 times 10. So a2 is equal to 5. Now that we have this, we can plug in a3 equals 1/2 times a2 plus a4. Now we know a3 is 8, and we know now we know that a2 is 5. And then we have a4. So I would just multiply by 2 on both sides. So we get 16 equals 5 plus a4. Subtract 5 on both sides. So we get a4 equals 11, and that's the answer to our question. We have, okay.
Sure. Oh, yeah. Joby, there's a QED counter there.
Yeah.
You can put your name and add
A slash.
a line.
Kind of like what Anna did.
Okay. Yeah. 1. Okay.
Having a state championship though, I don't know.
Okay. So we have right triangle, ABC. I'll just draw a right triangle. And it says that angle A is 45 degrees and AC is perpendicular to BC. And then if segment AC is 8, what is the length of AB? So if AC is perpendicular to BC, then they meet at C. And this could be either A or B. We'll just call this A. This will be B then. And it says we're looking for AB. and it gives us that angle A is 45 degrees, and it says that AC is 8. So we're trying to find AB, and we can plug in this to get this is called the hypotenuse, the longer side. We can use Pythagorean's theorem, which is a squared plus b squared equals c squared, and a being this side, b being this side, and c being this side. But first, we need to find b, or just CB here, and CB is actually just 8, because the angles in a triangle add up to 180, and since it's a right triangle, that's 90 degrees, and that's 45. They sum to 135, and then 180 minus 135 is 45, so the remaining angle also has to be 45. And just to prove it, we can draw a square here. So that's going to be double the angle of this one, so that's full 90 degrees. So this is just a square, so each side is going to be 8, and then so we have 8 and 8. Okay. So now we have a squared plus b squared equals c squared. We plug in a squared plus 8 squared equals c squared. So we get 64 plus 64 is 128 equals c squared. Now we just take the square root of both of these. So you get c equals the square root of 128. And I'm just going to simplify this. So the square root of 128 is the same as 64 times 2, like the square root of that. And the square root of 64 is just 8. So this is the same as 8 times the square root of 2, because like you square root that and the square root of that. So that means c is 8 root 2, which is what we're looking for. But as you'll notice, 8 root 2, this side was also 8. And that's not just by coincidence. If we have something called a 45, 45, 90 triangle, which is the angles, if we call it, like, let's say this side is x, then this side is also x because it's the same. And this side will always be x root 2. And to prove that, if we have a squared plus b squared equals c squared, a and b are the same. So we can just write that as a squared plus a squared equals c squared. So that's 2a squared equals c squared. We take the square root of that. So we get c equals a times the square root of 2. And that proves that if we have a 45, 45, 90, this side will be that side times root 2. So we get 8 root 2. And that is the answer, is 8 root 2. Okay, this one says, suppose x is a real number such that 2 to the x equals x plus 3. Determine the value of 2 to the 2 to the x over x plus 3. So, like, normally what you do is you find x and then you plug it in here. But the equation we have is 2 to the x equals x plus 3. And now we can solve for x, but that's going to be really hard. And honestly, I don't know how to do that. So instead, we can see that this is 2 to the x. And this right here is also 2 to the x. So that means, and 2 to the x equals x plus 3. So this right here is the same as 2 to the x plus 3. Or 2 to the 2 to the x is the same as 2 to the x plus 3. Because we can just plug in that for that right here. And then that's over x plus 3. Now, with exponents, if we have, say, like a to the x times a to the y, that's the same as a to the x plus y. because if we're multiplying and the bases are the same, then we just add the exponents. So we can apply that backwards here to get 2 to the x times 2 to the 3 over x plus 3 is the same thing, because here we just add the exponents. So this is the same as this. And now we have 2 to the x again, so we just plug it in again. We get x plus 3, like in parentheses, because it's this term, times 2 to the 3 over x plus 3. And then we have two terms that are being divided. So the same two things are being divided, so it's just 1. So we can cancel those. And then we're left with 2 to the 3, which is 2 times 2 times 2, and is 8. So that means 2 to the x over x plus 3 is 8, assuming that this is true. So that's the answer. Okay, this is my last one, and then we'll have Evan come up. So I'm just going to draw it first, and then I'll read the problem. Actually, I'll draw the circles first.
Do you have a darker? Maybe there's a.
Oh, yeah. Yeah, I think that's a little better. Oh, okay. That makes sense. Okay, so there's like a big circle, a medium circle, and then a small circle-ish. And then we have a rectangle that goes, it's not that good, a rectangle that goes like that goes around all these 3 circles. Okay, so
It doesn't touch the second medium.
no, it's like touching right here. Yeah, there's a gap right here. So the centers are, these centers of the circles make a triangle. And then it says that A, B, C. So ABC has side lengths 3, 4, and 5, and its points lie upon the centers of the circles. And then segment AB, this right here, is parallel to the rectangle. And then what is the probability that a randomly chosen point within this rectangle is inside one of the squares? So one thing to note is that it doesn't say this, but these circles and squares are tangent, meaning that there's one point right here that they touch, one point right here, and there's all one point where like everything touches. Just, yeah. And so the probability, like what it's asking is, say we pick a random point within this rectangle, let's say it's right here, that would not be inside the circles. And then we have one like right here that would be, and we're trying to find the probability that a randomly chosen point is inside one of the circles. So to do that, I would find the area. Here, let me write that down. I'll find the area of the circle A plus the circle B plus the circle C, and then put that over the area of the rectangle. So the first thing is we have the lengths 3, 4, and 5. So let's assign them to the triangle. So we can see that A and B are our biggest circles. So they're going to have the 5 length. And then C and B are the smallest two. So they're going to have 3. And the remaining one is 4. So this one is going to be 4. And now we want to find the radiuses of the circle. And so we could do some algebra, or we can just like see that if this is through 3, this would be forced to be 2, this would be 3, this would be 1, and 2. 1 and 2 is 3, 1 and 3 is 4, 3 and 2 is 5, and they add up. So the radiuses are going to be 3, 2, and 1. And we could do algebra to confirm that, but it just works with whole integers, so that's best. So we'll just do that. So let's find the area of circle A. So the formula is pi r squared. We have a pi now.
Yeah, there's a pi count there. Like,
Oh, there is?
yeah, we're not doing
1. Okay, so the area of A is going to be pi times 3 squared. 3 squared is 9, so it's going to be 9 pi. B is going to be 2 squared plus times pi, so plus, what is that, 4 pi. And then C is just going to be 1 squared times pi, so just pi. And then I'll just say 1 pi. And we can add these up to get 14 pi. So we already have the top of our equation done, and that was 14 pi. Now we just need to find the area of the rectangle. So it said that AB is parallel to the rectangle. So that means that this length right here across is the same as this rectangle here, because they're parallel. Now, we can just figure that out. So this is 3. We figured out that that's, well, so the diameter of A is going to be 6, because it's 3 times 2. And the diameter of B is going to be 4, because 2 times 2. And then we add those up to get 10. So this bottom side of the rectangle is going to be 10. So now we just need to find this length right here. So that's going to be a little more tricky than this one, because we can't just draw any line or anything. We'll have to draw multiple lines. So I'll just draw this one right here. That's straight down. This one goes straight up. And then if we have this, we can add this, this, and this line right here. So that's 1, and that's 3. So we're going to have 1 plus 3, or just 4, plus h. We'll just call this h. Plus h is going to be this right here. So let me just, it's getting a bit crowded there, so I'll just draw this triangle here. Looks like that. So we have, 5, 4, 3, or 3, 4, 5. And then we have h right here, which we're trying to find. So to find h, we're going to want to know, if we know this, then we can find that. But we can't figure out this or this, so we'll just name them. We'll call it x. So it's called this x, and since this full thing is 5, this other part is going to be 5 minus x. So that means that using Pythagorean's theorem, a squared plus b squared equals c squared, we can get, since this is the hypotenuse, that's c, so that means 16 equals x squared plus h squared. H squared. And I'll just isolate h here. That's going to be 16 minus x squared equals h squared. And then let's do this other equation. That's going to be, this is the hypotenuse, so it's going to be 9, because 3 squared equals h squared plus 5 minus x squared. And then let's also just isolate h here. What is that? That's 9 minus 5 minus x squared equals h squared. And you'll notice that this equation equals h squared, and this equation also equals h squared. So that means that 16 minus x squared equals 9 minus 5 minus x squared. So let's write that here. That's 9 minus 5. I'm going to erase some things. What's that? That's 9 minus, equals 16, 16 minus x squared. So this right here, like this 5 minus x squared, let's like expand that. And to do that, 5 minus x squared is 5 minus x times 5 minus x because it's just squared. And to expand this, we're going to do something called FOIL it, meaning we just multiply every number together. So multiply those, then those, then those, then those. And that'll get us the like expanded form of it. So 5 times 5 is 25. 5 times negative x is negative 5x. Negative x times 5 is also negative 5x. And then negative x times negative x is positive x squared, because two negatives multiply to a positive. Now we have this. So 9 minus 25 minus 10x, because there's two 5x's here, plus x squared equals 16 minus x squared. So since we're subtracting here, we can actually just distribute this negative sign. So that means we get 9 minus 25, and then that becomes positive 10x, and then negative x squared, and then equals 16 minus x squared. Now we can just add x squared to both sides to cancel out these x squareds, or these negative x squared. So that means we get 9 minus 25 plus 10x equals 16. So let's add 25 on both sides to get, what's 16 plus 25? Is that 41? Yeah. 41. So 9 plus 10x equals 41. 41 minus 9 is 32 equals 10x. And that means that x equals 32 over 10. And we still have some work to do, because we said that this length right here is x, and this is 5 minus x, and we want to get h. So let's plug in x right here, and then we have the hypotenuse of 4, so we're going to have 16 minus 32 over 10 squared equals h, and then h is what we want. Or should be h squared, yeah. And then now with this, let's just simplify this fraction to 16 over 5 squared. 16 minus equals h squared. And then now 16 squared is, here first. So 16 squared is 256. 5 squared is 25. And we have 16 minus that equals h squared. So now that we have this, 256 over 25 is the same as 10 and 6 25ths. 16 minus that is going to be 5 and 19 25ths. And then let's put that back into improper fraction. So 5 times 25 is 125. 125 plus 19 is 144 over 25 equals h squared. And then let's take the square root of both of those. So we get 12 over 5, because, right, 12 squared is 144, 5 squared is 25, equals h. So finally, we have h right here, and we said that 3 plus 1 plus h is this length right here. So now that we have that, let's add that up. 3 plus 1 is 4, so 12 over 5 plus 4 is going to be 32 over 5. So 32 over 5 is this length. And then now we just need to find the area of the rectangle. We said that this bottom length was 10. 10 times 32 over 5 is 320 over 5. And then we can just divide that to get 64. So that means, finally, our answer of the probability of putting a random point inside one of the squares is 14 pi over 64 is our answer.
I think you got a few more pi points. Hey, is that your final answer?
Yeah, I think so. 14 pi over 60.
Let me get the mic.
Yeah.
Thanks, Joby. That was great. You ready, Evan? Yeah, it's your turn. Wait.
Okay. Uh-oh.
It's okay. All right, sweet. Evan, I'll erase the board for you here. And put that guy in your pocket. You want me to clip this on your sweatshirt? Here. You just push those and it opens up. I'll erase it now. Okay, Evan's going to talk to us. Evan is our actual state champion.
Yeah. Which one do I do first?
314 factorial. How many zeros?
All right, so we have to find 314 factorial. It's like going to be a really long number. We're not going to count it. We're going to find how many zeros it ends in. So this can be expressed as 314 times 313, like all the way multiplying by things, so you get to 1. So what we want to do is, if you want to find zeros, you only get those when you get 10. And the 10 is from a 5 and a 2. So we're going to have lots of 2's, because every even number is going to have a 2. So we need to find the 5's, amount of 5's in 314 factorial. So find that, we do 314 divided by 5. That's me 1/5 of them. 1/5 of them have 1 5, which is, I don't know how many, 62? 62 point like something, but we don't care about that. So this is how many just have 1 5. To find the number at 2 5, it's like 25, 75. We're going to divide that by 5. We're going to get 12 equals 2 5s. And then divide that by 5 to get 2, which have 3 5s. That's going to be 125 and 250. And then we add these up, and we get 76, which is the inverse of 67. Mm-hmm.
So you have 76 5.
Yeah.
But 5 doesn't make a 0, does it?
What?
So you're looking for the number of zeros at the end of 314 factorial?
Mm-hmm. No, 5 and 2.
Oh, I wasn't paying attention. Sorry.
Of course, just a bad boy,
How do
Corey.
you know you have no 2's?
I told you if you're listening.
Okay. Take it all back.
Okay, well, what's the answer? 76. Oh, I do. Joby, do you want me to add one for you?
Wait, no, for you.
Wait.
You both have
I get one. What's next? Ratio of number of 4-digit positive integers that have 4 different even integers, number of 4-digit positive integers at 4 different odd digits. So we have to count them. So we'll start with the even ones. There are 4 digits. How many different options do we have for this one? 4. Because you can have 2, 4, 6, or 8. 4. This one, how many do we have? 4. Because, well, yeah, but then they're different, Joby. So we're going to have 4. Let's say this is like an 8 and then a 6. They can't repeat later. For this one, we're going to have 3. because we can't use these two. 5 minus 2 equals 3. And this one we're going to have 2. So this times this times this times this equals 6 times 16 equals 96. Over, now we're just going to odd digits. For this one, there's no 0, so we don't have to worry about a 0 going there. We have 5 by 4 by 3 by 2 by 1, which is just 120. 96 over 120, and we have to simplify this. Very hard. 96 over 120, we can divide by 4, I think. Over 30, what's 96 over 4? 24. We can divide this by 6. 4 over 5. 4/5. Yep. What's next? Oh, this one. So this one we have a box. I will not draw it because I'm not a good artist. But we have 35 for one surface area, 45 for another one, 63. And we have to find the volume. Uh-oh. So basically what we have to do is try to substitute side lengths in. And in this case, it's easy. 35, it has to be either 1 and 35 or 7 and 5. 1, 35. And we see this isn't going to be good. So we know this has to be 7 or 5. Has to be 7 because that's by 5. So this has to be 7, 5. This over 7 is 9, and that works for that too. So the edge lengths are 7, 9, and 5. Multiply them together to get 235, I think. Is that the right answer?
I don't know what the answer is, but
You have to draw it. Probably. Cos by 50. Is it? No, it's 335. Is it? 315. 315. Which is like 3.14. And then this last problem, yeah, we don't have it on the board, right? Tell us from scratch.
there are a couple here.
This is the problem I asked Corey to make for me, but he didn't do it.
Yeah, I couldn't.
So we have a pentagon. Like a crown. And we have the integers, the vertices U, Z, E, I, and L. And we have to find the area of pentagon Uzil. And this length is 35. This length is 3, right? This length is 3 as well. Wait, what did I do? No, I forgot what. It's 1, it's 1. This is 1, this is 3. Right. And this is, it's like a mind trick. It's a mind trick, okay? This is not a right angle. No. So to find the area of Uzil, we have to have a pentagon, which is not a pentagon. Well, like not a rectangle. It is a trapezoid, because those are not the same. Minus this triangle. We're going to find that. Pentagon, it is 3 plus 1 divided by 2 times 35. This is 2 times 35, 70. Minus the triangle, 2 times 3 over 2, 3. 70 minus 3 equals 6, 7. Yes. And that's the answer.
Thank you, Evan.
Happy to help.
That was great.
Mm-hmm.
This is a nice challenge if anyone wants some homework. It's doable, but thanks, Evan. Nice work, dude. Yeah. No, it was okay. Huh?
Can I go home?
You can go home. Yeah.